Hello friends, welcome to my YouTube channel Physics Scientist. Please like and subscribe to my channel. Let's talk about this very important topic, carbon nanotubes. A carbon nanotube is a tube-shaped material made up of carbon having a diameter measuring on a nanometer scale, 10 to the power minus 9 meter. The graphite layer appears somewhat like a rolled up chicken wire with a continuous unbroken hexagonal mesh and the carbon molecules at the apexes of hexagons. Carbon nanotubes have many structures differing in length, thickness, and in the type of helicity and number of layers. Although they are formed from essentially the same graphite sheet, their electrical characteristics differ depending on these variations, acting either as metals or as semiconductors. Carbon nanotubes typically having a diameter ranging from 1 nanometer up to 50 nanometer. Their lengths are typically several microns, but recent advancements have made the nanotubes much longer and measure in centimeters. Nanotubes can be categorized by their structure as single-wall nanotubes, multi-wall nanotubes, and double-wall nanotubes. Then let's talk about the potential applications for carbon nanotubes. Carbon nanotube technology can be used for the wide range of new and existing applications. Conductive plastics, structural composite material, flat panel displays, gas storage, anti-fouling paint, micro and nano electronics, 10 to the power minus 9 meters, radar absorbing coating, technical textiles, ultra capacitors used, atomic force microscope tips, batteries with improved lifetime, biosensor for harmful gases, extra strong fiber. These are the applications for carbon nanotubes nowadays. Now talk about the electronic transport in carbon nanotubes. How? A metallic carbon nanotube can be considered as a very thin wire, but the conduction of charge is very different from a normal macroscopic piece of wire. Individual carbon nanotubes would be able to carry useful amounts of current, microampere each, around a nanoscale device. Their use in electronics, however, could well emerge before truly nanoscale devices are available. In conventional SI-based integrated circuits, the demand for every smaller components and the thinner copper wires between the components is producing a serious heating problem. The thickness of copper interconnects is approaching 100 nanometers, and it is not just that the thinner wires have higher resistance, but it becomes more difficult to maintain uniformly in the wire without faults and hotspots. Major chips manufacturers such as Intel are actively researching the use of carbon nanotubes as interconnects. Carbon nanotubes electrical conductivity of the range is 10 to the power 6 to 10 to the power 7, and their thermal conductivity is greater than 3000 watt per meter per Kelvin. In automotive industry, carbon nanotubes imparts conductivity to plastic exterior parts such as fenders, mirror housing, and door handles, which are subjected to the electrostatic painting processes. Carbon nanotubes have been incorporated too in thermoplastics as substitutes for old metallic made automatic parts, thus decreasing the weight of the parts by more than 50% in some cases. There are major carbon nanotubes unique properties and various products formed with a newer and compatible modern processing technology now offers unseen possibilities for creating new engineering materials for automatic applications. First of all, we have a property, mechanical property. The carbon nanotubes are strongest material known. The strength arises from the strong covalent sp2 bonds among the carbon atoms in the graphene sheet. And it is not much different in nanotubes. And next, we have in the marine industry, carbon nanotubes have been integrated into composites for mechanical reinforcement. Carbon nanotube based products also offers architects, specifiers, engineers and builders an array of flexible and cost efficient solutions. Next property is thermal properties of carbon nanotube. Having observed all that the remarkable properties of nanotubes, it should be no surprise that they also display a huge thermal conductivity, and aeronautic sector is using carbon nanotubes for flame retardant production of fuel tanks and exhaust parts. And number last property we talk about is the optical properties. Photographs of the size dependent emission spectra of HGS and cadmium sulfate quantum dots show that small quantum dot observes and emit blue-green light, and large dots observe and emit red light. Thank you very much. If you like my lecture, please like and subscribe to my channel. Thank you very much.